Today we are going to discuss about the graphical method in linear programming problem. So in exam mostly they will ask the question like that, explain the graphical method with an example. So example means here this is an objective function and these two are the constraints. So graphical method ki manaki maximize or minimize ఏదైనా ఉండొచ్చు. So z equal to అంటే ఇప్పుడు ఎగ్జామ్లో if they ask with an example means we have to define the objective function like this. Any values we have to define the objective function like this and constraints like this, less than or equal to constraints. In this problem we are going to discuss the less than or equal to, and in another problem we are going to discuss about greater than or equal to. Okay, these two are the constraints. In graphical method, first what we have to done is for equation 1 and constraint 1 we have to remove the less than or equal to and make it as equal to. So 10x1 plus 20x2 ఇక్కడ less than or equal to ఉంది కదా, దాన్ని మనం equal to 120. So less than or equal to inequality should be taken as equality. So put x1 equal to 0 in this equation. If x1 equal to 0, 20x2 equal to 120. So 20x2 equal to 20, x2 equal to 120 by 20, that equal to 6. Here in this table x2 equal to 6. Next in the same expression put x2 equal to 0. x2 equal to 0 means here x2 equal to 0. So 10x1 equal to 120, x1 equal to 120 by 10, that equal to 12, x1 equal to 12. So this is the x1 x2 values for constraint 1. So points here we get the points 0 comma 6 and 12 comma 0. So next constraint is take 8x1 plus 20x2. Here 8x1 plus 20x2 less than or equal to 80. So make that inequality to equality equal to 0. Again put x1 equal to 0 and x2 equal to 0. So this in this table x1 0, then we will get x2 equal to 10. When x2 equal to 0, x1 equal to 10. So these are the points. Okay. So based upon these points we have to plot a graph. So this is the graph. So in graphical method we have to construct a graph. This is 1 centimeter, 1 centimeter, 1 centimeter, or else we can directly draw on graph sheet also. Okay, so first point, based upon the first constraint we will get 0 comma 6 and 12 comma 0. 0 comma 6 lies on y axis and 12 comma 0 lies on x axis. This is x axis and this is y axis. So draw a line. So next, based upon the second constraint we will get 0 comma 10 and this is 10 comma 0. These two lines intersect at a point 8 comma 2. So this is the rough graph I have drawn. So that's why 8 comma 2 we మనకు క్లియర్గా రాదు 8 comma 2. So if you draw on a graph sheet then we will exactly get 8 comma 2 point. So that's why I am saying that in exam you have to take 1 centimeter, 1 centimeter, 1 centimeter graph. So then we will get exact 8 comma 2 point. Okay. So based upon the feasible region. So feasible region means in this constraint they have given that less than or equal to. So less than or equal to means always the shaded part should be towards the origin. If in the problem they will give greater than or equal to 0, then away from the origin. That problem we will discuss in next video. So this is the feasible region, and feasible region always get the intersection of the two lines. So this is the line obtained from second constraint and this is the line obtained from first constraint. So this is the intersection region. That's why I have mentioned this as a feasible region. In feasible region we will get a point 0 comma 0, 0 comma 6, 8 comma 2 and 10 comma 0. So maximum z, this is an objective function. Substitute 0 comma 0, 10 comma 0, 8 comma 2 and 0 comma 6 in these equations, then we will get a values. So the z value is maximum. Based upon these values the maximum value obtained at point C 8 comma 2, then x1 equal to 8 and x2 equal to 2, then optimum value is 128. So in this graph suppose we will shade this region. Okay, based upon first line we will shade this region. Both shaded parts intersect at the feasible region only. So that is the intersection part. That part should be selected. Okay, This is a graphical method. In exam, if they have asked for explain graphical method with an example, we can frame any constraint and any objective function. Okay, thank you.